So today we're going to look at what do science teachers need to know about the new standards document. And to do this, we're going to review what 3D science learning is, which is what is outlined in a framework for K-12 science education. So studying that framework is going to be helpful in understanding the new Arizona science standards. We're going to kind of look at how to maximize the 3 dimensions in the standard and where you can find more information about those 3 dimensions. We're going to take a quick sneak peek at the vertical progression, and we're also going to focus on our disciplinary core ideas with a video. And of course, you'll be able to ask me any questions at the end of the webinar, but please ask as we're going through. So first, we're going to start with 3-dimensional science instruction, and really, what is that? And 3-dimensional science instruction includes the core ideas, the cross-cutting concepts, and the science and engineering practices. So we have our Dimension 1, Dimension 2, and Dimension 3. All 3 dimensions have been put together in the standards in mind that you can use any core idea with any science engineering practice and any cross-cutting concept to help it make sense to students. There isn't a 1-to-1-to-1 ratio, and they can be used in any order together. So let's go over those 3 dimensions in a little bit more detail. The first dimension outlined in a framework is the science and engineering practices. These describe behaviors that scientists engage in as they investigate and build models and theories about the natural world, and the key set of engineering practices that engineers use as they design and build models and systems. Now, the framework used the term practices instead of science and engineering skills because they really wanted to emphasize that engaging in scientific investigation not only requires the skill, but also the knowledge that is specific to each practice. And that's why we can't separate the 3 dimensions. And you'll see that in the standards, the 3 dimensions are there. The science and engineering practices work with the disciplinary core ideas and the cross-cutting concepts to give the student an overall feeling of their science education. Now, the cross-cutting concepts have applications across all domains of science. There are 7 cross-cutting concepts, and the framework emphasizes that these concepts need to be made explicit for students because they provide an organization for interrelating knowledge from various science fields into a coherent and scientifically based view of the world. So the cross-cutting concepts have been around for a long time. You've even seen them in the introduction or something similar to them in the introduction of the 2004 Arizona State Science Standards. So why are we making this to be such a new thing now? And that's because now they live and appear and are in the standards document with the learning progression in the standard. So they are very apparent in the standards now. And we also need to change them from being a tool for teachers to a tool for students. If the students know and understand why they are using the cross-cutting concepts in their K-12 schooling, they will be able to internalize those tools and apply them in other concepts and in their future. Now, the 3rd dimension are the disciplinary core ideas. And the framework has these there to help focus science education, and that means instruction, curriculum, and assessment on the most important aspects of science into one distinct learning progression, kindergarten through 12th grade. And these learning progressions from a framework were referenced as the 2018 Arizona State Science Standards were written. But in Arizona, we used one more document besides the framework, even though our talk today is going to be mostly over the framework. I do want to point out that we did use Working with Big Ideas of Science Education as our 2nd document. And here you can see the 14 big ideas of science education. And in our standards document, we turn them into the 13 core ideas of knowing and using science. So the knowing science would be in the physical science, earth and space science, life science, and using science. I'm just going to give you a couple seconds to look at the chart, and you can see how similar the wording is from the document Big Ideas to our core ideas of knowing and using science in the Arizona State Standards document. You can see that the wording is very similar and exact in most cases. In the standards document, you're going to see the core ideas for knowing science and using science arranged in this chart. Knowing science is on the left-hand side, using science is on the right-hand side. And then each standard is going to have an intersection between knowing science and using science, and I will go over that in more detail in a little bit. But every standard has a knowing science and a using science. So we kind of briefly went over the three dimensions. We have our science and engineering practices, our cross-cutting concepts, and our core ideas. Here is a sample standard. It says to plan and carry out an investigation to demonstrate that variations in temperature and/or pressure affect changes in states of matter. You can see here that we have our science and engineering practice, which is plan and carry out an investigation. And in almost every standard, not all, but almost every standard starts off with a science and engineering practice, and it is bold. And when you download the PDF, you can also see that some of them have links to parts of the framework where you can learn more about planning and carrying out an investigation. Or if it was develop and use a model, it would link to develop and use a model in the framework. So you can really get a lot of information about the standard from going to the framework and looking at that section. Then the core idea links to P1, and here's where I say that there's always a knowing science and a using science connected. So the P1 goes back to all matter in the universe is made of very small particles. I'm just going to go back one page. And here we have the connection of P1, all matter in the universe is made of very small particles. And then we had a U1 in our standard, U1 right here. And students need to look at this standard through the lens that scientists explain phenomena using evidence obtained from observations and/or scientific investigations, and that evidence may lead to developing models and/or theories to make sense of phenomena. So that is the lens that students would look at that standard through. If they were looking at it through a lens of U2, then they'd be looking at that standard as in an engineering or to solve a problem or to create a product. But it would be a completely different lens to look at that standard through. If it was a U3, they would look at it through the lens that applications of science often have both positive and negative ethical, social, economic, and or political implications. So that U is really important in telling us what lens we're going to be learning this standard through. So again, we have our science and engineering practice. We have our core idea. And you haven't seen the cross-cutting concept yet, but I will show you a cross-cutting concept when we look at the full document. But for this standard, on the document page, it identifies cause and effect and system models as the cross-cutting concept. So here's the standard we just looked at on the standards page. We have a learning progression here. the research that was used to write the standard, and then the cross-cutting concepts and how they were identified. You're going to notice that scale, proportion, and quantity and system models are bold. And in kindergarten through eighth grade, there are identified cross-cutting concepts that are like an overarching theme for that grade level. And for sixth grade, scale, proportion, and quantity and system models are the two cross-cutting concepts that have been identified as the overarching cross-cutting concepts for the grade level. But there was still a really strong connection to cause and effect in the standard, so the working groups left it in, just did not make it bold so that the teacher could still see that scale, proportion, and quantity and system models are the focus for the grade level. So the standards were written so that they have these core ideas of knowing science in every grade band, not every grade level. And they're going to spiral in a progression through kindergarten all the way to 12th grade. So if we look at P1, it is taught in 2nd grade, 5th grade, 6th, 8th, and high school, and is seen that many times and is built upon across those grade levels. So if you look here, it is really important that the 2nd grade teacher make sure and they teach their standards on P1, that all matter in the universe is made of very small particles, because if they don't, then the first time they see that topic is in 5th grade. And for each of the core ideas of knowing science, you can see here their progression and when and where they are taught from kindergarten through 12th grade. Now, the framework was really important in shaping our new Arizona State Science Standards. And it is a free download. You can download this right now for free. You just give your email address and you'll get the full book. It outlines scientific literacy and that K-12 progression and what the 3 dimensions of science instruction are. So, for example, Chapter 3 of the framework is dedicated to Dimension 1, the science and engineering practices. Chapter 4 is all about Dimension 2, the cross-cutting concepts. And starting with Chapters 5, continuing into 6 and 7, are the disciplinary core ideas in physical, earth and space, and life sciences. If you would, please just take a moment to read this standard. Okay, so here we can already see that our science and engineering practice is to use evidence to construct an argument. Our core idea of knowing science is going to be in L2, so it's going to be a life science. And we're going to be looking at it through the lens of L3, that science has social, economic, and political implications. Here is the table of contents from a framework for K-12 science education. We did say this was an L2, so it is a life science, so I pulled up the life science table of contents. Just reading the standard, in the chat box, let me know, where would you go to get more information about this standard? Just looking at the title of the reading the standard, looking at the title of the topic in the table of contents, where would you go? Good. So you see that it is about the environment, so maybe we could look in LS2 ecosystems because we might learn about the environment there. I'm getting a lot of LS2. So I'm going to have you go, and either you can use the link to the framework that I've given you in the chat box, or I'm going to give you a different link that you can go to as well. That is going to take you to exactly where I would like you to go. And I would like you to read the introduction to LS2.A, which would be right here on the framework on page 142. So when I send you the link, read the introduction, and then read the K-12 progression and grade band endpoints for LS2A, and let me know if it gives you any more insight on the standard. So again, I'm going to send you a link, read the introduction to LS2A, and the K-12 progression and grade band endpoints for LS2A, kind of focusing on the by the end of 8th grade band. And let me know if it gives you any more insight into the standard. I'm going to send you the link now. Now that you've gotten the time to choose, do you just want to do the quick link or do you want to download the full framework? I'm going to give you guys about 4 minutes to read those sections. And when you're ready, go ahead and start typing in the chat box if it gave you any more insight onto the standard 6.L2U3.11. Okay, so once you've read the introduction and the progression, let me know if it gave you any insight onto the standard. Because now that you've really had a chance to look at that standard, you can see that it's pretty broad. Does reading the progression from the framework give you insight on where that standard is coming from? Good, so you really got to see that the organisms depend on their environment, and yet they still have interactions between them. They still have competition and other things that they need to be able to survive. And yes, if you're looking at the whole progression, in the early grades, the emphasis is more on how the organisms live, and then what they need to thrive and really develop. And then in the higher grades, there's more of an emphasis on competition, carrying capacity, threats, other factors that can make it difficult to survive. Good observation. Now, reading the standard again, did that progression give you the whole picture, or do you feel that something is missing? Yep, and you guys got it. There's not much information about human activities, and I picked this standard on purpose because it is coded a life science, but our standards now are very broad, and they're there to help teachers be able to have the flexibility to make connections with students, and for helping those students make those connections to other content and really focus in on those cross-cutting concepts. So I pulled this progression, and it's just by the end of 8th grade, so it's just that 6-8 progression, from Earth and Space Science 3.c from a framework for K-12 science education. Go ahead and just read this slide and see now if this gives you the full picture of our standard in 6th grade. So now you see that the students really did need that life science knowledge for our knowing science to be able to really focus on their U3, the social, economic, and political implications of science and our impact on the environment. So sometimes it's going to take more than one section of the framework to make full sense of one standard. And to help with that, we have the learning progression on the standards page. So here you're going to find the standard that we were just sampling. And there are other standards in this section. And then on the right-hand side, you're going to see the learning progression, key terms, and cross-cutting concepts. So for this standard, we definitely needed to understand the L2 2 portion that you guys read from page 150 to 152 of the framework. But we also needed to understand that human activities have significantly altered the biosphere to fully understand this standard. So we have page numbers to the framework or Working with Big Ideas, whichever document had a closer fit to our standards, to help with the research behind the standard. So here we have the framework, page 152, and the framework, page 196, give a full view of that standard. Now this is a good time to point out that the left side of the document is the standard. It's what should be taught in the classroom. The right hand is the support material, that research that helps you figure out some insight where the standard came from. But again, it is the standard that is taught, so really focusing on the wording here. And there is even some stuff in here that you may not need to teach this standard. It's just background and insight and a little bit of support material to help understand the standard itself. So again, the progression is not what should be taught. It is the research that was used to write the standard. It gives insight on the standard and a little bit of perspective about the standard, but should not be used in determining exactly what to teach. So let's look at where we could find even more information to really maximize those 3 dimensions in the standard. So again, we have the same sample standard. We know that the science and engineering practice is to use evidence to construct an argument. And even though these standards are new to Arizona, there are many states that are framework-based states, and the Next Generation Science Standard used the framework to write their standards. So even though our core ideas are not exactly the same as NGSS, we do have a couple things in common with them, and that would be the science and engineering practices and the cross-cutting concepts. So NGSS and NSPA have worked together to kind of put together what using evidence to construct an argument would look like across the grade bands. So there's a K2 section, 3-5, 6-8 in high school. Because this was a 6th grade standard, I pulled out the 6-8 grade band. And take a look at these bullets. Do these bullets feel like they are appropriate for a 6th grader to be able to use and construct an argument? So just take a second and look at them. Good. I'm glad you guys see that they could be appropriate for 6th grade. And it really does break down what you should be seeing students doing when they're working with that practice, use evidence to construct an argument. And this document, the NGSS Appendix S, has all 8 science and engineering practices broken down this way. And in a couple of days, you're going to get a confirmation email for the webinar, and you're going to get a resource page with everything that I have talked about in this webinar. So you will get a link to this. They also have Appendix G for the cross-cutting concepts broken down by grade bands, so you can see what's appropriate for students in the 6th grade to be finding patterns or using and thinking about systems and system models. But I have another resource that is also very helpful, and it is STEM Teaching Tool number 41. So let's say you were looking at the last standard and you wanted to focus on cause and effect. It's a bold standard, it's a bold cross-cutting concept in the standard, but what does that look like being used in the classroom? And with the cross-cutting concepts, what you want to make visible is student thinking. What are students thinking about? What they're learning? And how can I get that out of them in a way that makes sense? So, for example, here are some prompts, and these can be used in many different ways, from just asking students questions or getting students to ask other students questions in these kind of frames. But you could ask them what caused the patterns you observed. How do you know that A caused B? And you're getting them to think about what they're doing and analyzing in a different way. You can even have them draw a diagram that shows how changes to one component of their system affects components that are not directly connected to that component, or any other ways of showing student thinking. And there are prompts for all 7 cross-cutting concepts in this document. So I kind of gave you a resource to help you with the science engineering practices. There are a couple resources to help you with the cross-cutting concepts. But really, in short, what I want you to get out of a framework is that it is a free document. You can download it and use it to help you understand the new Arizona State Science Standards. Another thing I wanted to show you is a new document on the ADE website. It is the core ideas of knowing science, vertical progression, and kind of gives you a storyline of what is happening with the K-12 progression of those core ideas. So this is the storyline of L2, life science, and how students learn about how organisms require a supply of energy and materials for which they often depend on or compete with other organisms from when they start in kindergarten and as they move through 12th grade. Here's continuing on to high school. And learning about organisms and their energy starts all the way in kindergarten and will continue this spiral throughout their education until they graduate high school. I want to show you where you can find this document on the website. So here's the ADE website in Standards and Science. There are some overview videos and some educational shifts on the document, as well as the recorded webinar from the first session. But if you continue, here is where you download the entire standards document or by grade band. And then here under Arizona Science and STEM Support Materials, one more down, the Arizona State Science Standards Vertical Progression of Knowing Science. You click this button and you will get the full document with all of the 10 core ideas of knowing science. So now that we looked at that vertical progression, we saw that these ideas are going to spiral throughout their education. Why is that so important? Why did the writers of a framework for K-12 science education really focus on that progression? And then why in Arizona did we decide to create our standards around core ideas instead of discrete facts that students memorize? And I have a short video. It is about 5 minutes. There it is. And I'm going to send you the video link in the chat box so you guys can go and watch the video. As you are watching the video, please think about what are disciplinary core ideas, or in Arizona are core ideas? How are they useful? And how are they different than our last standards were written? What makes these so unique to these standards versus our old standards? And then how or why do we want disciplinary core ideas to progress through the grades? So I'm going to leave this screen up so you guys can go back to these 3 questions. And please think about these 3 questions as you watch the video. Now the video was designed for NGSS, but since we are also a framework-based state, this video works for us for now until Arizona makes its own materials for the standards. But it's just going to give you an idea of why we focused on core ideas. I'm going to set a timer for 6 minutes. I can see that the majority of you are coming back to me and have finished your video. If you're finishing up your video, that's fine. But yes, the core ideas show the larger picture and allows them to see more connections to the world around them, and also kind of see that science isn't just separated into life, earth and space, physics and chemistry, but they are connected. Some other things to point at, that students need to provide the evidence to support their claims. And it's about students doing and using those core ideas across multiple phenomena. Another thing I saw that the video said was that no more memorizing facts, that there's a difference between the students knowing science versus repeating back facts to their teacher. And that was really something that I took away from the video. And there's definitely that K-12 progression that is there from the very beginning in kindergarten all throughout the grade levels. And it's there to increase the thinking ability of the students. Good, I'm glad you guys got all of that out of that video. I just quickly want to go over the Arizona Standards and Assessment Transition Implementation tentative timeline for you guys. We got new standards this fall of 2018. So this school year, the ADE asks to continue using the 2004 standards, and in the spring of this year, we will give the AIM Science assessment exactly the same as it was last year, computer-based in grades 4, 8, and high school biology. Next year, however your district decides to implement the new 2018 standards, go ahead and do so. The same AIMS exam from this current year will be given next year in grades 4, 8, and high school biology. Let's quickly look at year 2, 2021. Continue to implement those 2018 standards, and we will have the field test for the new state assessment. Go over to this box and look at how this field test is going to look. It's going to be given in 5th grade, covering standards from 3rd, 4th, and 5th grade. It will be given in 8th grade, covering standards from 6th, 7th, and 8th grade. And it will be given in 11th grade, covering all 28 essential standards. So it's a little bit different than it is now. Currently on the schedule is the AIM Science from the previous years, meaning that 8th grade could be tested twice in 1 year over AIMS and the new exam. However, the ADE has requested a waiver from the United States Department of Education, because they're the ones who say that we give the AIMS test or not. And they don't know what that's going to look like, and they haven't heard back yet, but as soon as they find out if their request for the waiver was accepted, then this will no longer, hopefully, be on the schedule, or in the worst case scenario that the waiver is just for 8th grade and 8th graders don't have to be tested 2 times in 1 year. The rest of the time is for you guys to ask me questions. Please know that it might take 24 to 48 hours for you to receive your certificate and your resource list. You will be contacted by Sarah Sleesman at the Arizona Department of Ed. If you have any questions, please feel free to email, but right now is your time to ask me questions. I'm glad you got a lot out of this. The framework has a lot of really good information for us. The Arizona Department of Education requested a waiver from the U.S. Department of Education. When you mean hard copies of this, do you mean the framework or do you mean the standards? Okay, so the framework is available for a free download, and you get the full book, beginning to end, in a PDF. It's color, and in the upper right-hand corner, I know you'll see a price when you first go to the website, but in the upper right-hand corner, it will say download for free. Do the free download, but there isn't going to be hard copies distributed unless you wanted to purchase one yourself. Or if you go to an Arizona Science Teachers Association trainings, you can get free frameworks from there too, from some of their trainings. Ooh, that's a big question. So the question is, do you have a list of recommended curriculum? Do you believe the new standards can be implemented with the current curriculum resources? There is not a list of recommended curriculum. That's where it gets to be a little difficult. Can they be implemented with current curriculum resources? If you're looking at, can you apply the science engineering practices and the cross-cutting concepts to current curriculum resources? Absolutely you can, but yes, I do understand that does take some work from the teacher. So definitely work with your district and see what their plan is for new curriculum for your particular classroom. There are districts and schools that have already begun teaching these standards, yes. Do they have some example lessons or feedback about how students are receiving it? I'm not quite sure about the student feedback, but teachers have been really happy with it, and we can ask around and see if there are some example lessons that they would be willing to share. The next set of webinars is going to focus on 3D instructional units and how teachers can take resources that they have or find resources and evaluate them for their ability to work with our Arizona State Science Standards, and just some nice tips and tricks on how to create good 3D lessons for your classroom. I agree, example lessons would be great. The ADE is not allowed to, or is not able to, give out curriculum because Arizona is I want to make sure I say this correctly. It is a state where it is local control. The schools and the districts have control over the curriculum that they provide. So the ADE is not allowed to do so. So that's why I recommended you ask your school district and your curriculum specialists there. So as you guys are starting to think about resources and what you could bring in, if you find something that is NGSS aligned, the science and engineering practices, the cross-cutting concepts will be the same. You do just kind of have to be careful about where they put that core idea in their progression versus yours. So high school, it's a little bit easier because you know what course it goes into. But let's say you find a resource and it is set at 5th grade for NGSS, but it is 3rd or 4th grade in Arizona. You would have to think about the reading level of the assignment and bringing it down to the level that's appropriate for the students. It's not impossible to find resources. It's a little bit more difficult with where does it actually align to Arizona. I do think that the NSTA conference would be helpful. It will be very much NGSS focused, but I still think that anything that you can learn about the science and engineering practices and the cross-cutting concepts then can be applied to our content really easy. If you understand those concepts, then applying them to particular content would be a lot easier for you. And if your principal suggests and is going to pay for it, I say go. It's a great experience. And if you do have the opportunity to join me for the next few webinars on the 5 tools, then we will definitely go into standards, into at least one sample standard really deeply and try to focus on how we can find or make our own curriculum for that standard. I agree. I definitely have similar issues with having as many teachers as I do and getting them to switch to the new standards without resources. I agree, but we will get there. Ask me any questions you want. So while you're typing your question about testing, again for resources, if you can find something that is NGSS aligned, I just feel that it can work. You just have to have enough knowledge base of the Arizona standards along with the science engineering practices and core ideas to create it something that will work for an Arizona standard. So getting your knowledge base around the framework and working with the big ideas and the standards document itself will help make that process be a lot easier. So it's not like there's nothing out there, and publishers are trying to work and get their standards aligned to, or their texts aligned to Arizona. So as soon as those standards pass, they felt the pressure and they know it's go time to do so. It's only been a couple months, so there isn't really anything to Arizona yet, but I know they're working on it. Or even if they're not working on that, they're going to look and see where their materials do align with Arizona standards and try to make those connections. Okay. So going to the testing question, it asks, for example, if the test in 8th grade, it covers the material from 6th, 7th, and 8th grade, correct? Correct. So whether you're a district that is K6 or K5, then you have middle school, Either way, the test in 8th grade is going to cover standards from 6th, 7th, and 8th, which are nationally the middle grades, and are grouped together in a grade band, and you'll see them grouped that way in the framework. I guess with a question about the student coming from another state or even another school district or a different school, it would follow the same rules that we have to deal with when we give the test in 4th grade, and we had that 4th grader for the very first time in this state. They still do have to take the test. So it's not, even though it seems like this test is going to cover more standards, it's really not a lot different than when you do get that student from another state or from another district in just so happens to be that testing year. We do the best with what we can with that student. We do not know enough about the test to know the distribution of the grade level questions. We do know that Pearson has the contract to write the test, and they have written 3-dimensional exams for other states that are framework-based states or who have adopted NGSS. So we do know that the focus is on the 3 dimensions of science instruction, and that it will be a predictive test. So it will see how the students are answering and select questions from their abilities. But we don't know the item types yet, and that distribution of how many 6th grade, how many 7th grade, and how many 8th grade questions will be on that exam. Yes, I agree. These standards do have that code, and in the first webinar, if you watched that first recording, I went over that code and how important it is, and you will see K in front of the code, or 1st grade, 2nd grade, 3rd grade. The standards are coded by grade level, so yes, it would be much easier to kind of figure out where the students are at. I don't want to, say that a teacher did poorly, but if there was a teacher that was a 6th grade teacher and 6th grade was really low on the test, you can find that out pretty easily. I'm glad you like the vertical alignment document. I find it really helpful too. I think it was just put on the ADE website last week, so still pretty new. In the vertical alignment document on page 12, you're also going to see that color-coded distribution of core ideas of knowing science that I showed you in the webinar, which I find that really helpful in giving PD to my teachers, because they see how important it is that you need to teach that particular set of standards in 2nd grade or in 4th grade or in 6th grade, because if you don't, you can really see where you're going to kind of interfere with that student's understanding of that core idea. And we are definitely past time. If you have more questions, feel free to ask them, but if you don't want to seem rude as leaving the webinar, go ahead and leave the webinar at 6:13. But feel free to ask me questions. I'm fine with staying a little later. Terry, if you have any questions and you want to ask me before you have to give in-service next week, just shoot me an email. Do you mean transition fourth grade as transitioning them to all of the new standards? So, for example, in my district, we are focusing on kindergarten, 3rd, 6th, and 9th grades next year, because those are the first years that will be tested in the official testing year. Or are you asking because 4th grade currently tests and then they're not going to be testing anymore? So someone did ask earlier if there are any schools that have started the transition process and how have the teachers felt about it. And the students learn so much more from doing science and engaging with the science and engineering practices that the 2 classrooms that did the test of the new standards, every single one of their kids were meets or higher on the Ames exam. So I say transition when you can. It's not going to hurt the kids most of the time, unless your Ames scores are very, very, very good right now. They're either not going to change or they're going to be a little bit better. But from what I've seen, teachers who have been doing the 3 dimensions in their classroom have seen more success on Ames than just sticking with what they're currently doing. So even though we're focusing as a district here on kindergarten, 3rd, 6th, and 9th, we're telling all of our other grades to still use your same content, but really focus in on those disciplinary core ideas and cross-cutting concepts. Bring them into your classroom as much as possible. Yeah, anytime. right, thank you guys. I'm going to go ahead and stop recording and end the webinar. I hope you have a great rest of your week.